dilation. So quick chat in, what is dilation? It's not in the Pear Deck, but just chat it into the chat. What is, you can just privately message that. Just want to check in to make sure everyone's on the right page with this. Great. Jimena, will you share what you wrote to me in the chat? I really like that.
When a shape gets bigger or smaller.
Yeah, perfect. Who agrees with Jimena? Can you write that you agree in the chat or give a thumbs up in the camera, please? Okay. So for our warm-up today, all, some, or none, we're talking about congruence and similarity. Here's the question. So it says, choose whether each statement is true in all cases, in some cases, or in no cases. And if so, a lot of you are really great, really on the money for the first one. Miguel, if you could come off of mute and talk a little bit about your answer to the first one, that would be awesome. So the question reads, if two figures are congruent, then they are all similar. Is this true in all cases, some cases, or no cases? What did you, will you expand on what you wrote, Miguel?
I think I remember in the assignment from yesterday that it said that if two congruent, if two figures are congruent or very similar, they are the same. I'm not so sure because my memory is not that good, but I'm pretty sure it said that if not all of them, if not most figures, if they are the same or congruent, they are like practically the same in a way.
Yeah,
Again,
for sure. Anything else? Does anyone want to add anything else to that? Or Miguel, too? And you can also put in the chat. Dilation. So if two figures are, definitely recommend writing this down, taking a picture of these. I know that the third one might be confusing, so I'll expand on that. I'm going to try and expand on that later in class because I don't have an image. But yeah, I would definitely write those down. Any questions right now? Any questions? Okay. Thanks, Jimena. Good. So I'll go to the next slide. Here we're going to transition to our big ideas. This is the meat of our lesson today. We have three big ideas that's going to build on our similar polygon figures. So the first big idea is that similar figures have congruent corresponding angles and proportional corresponding side lengths. So this means that all the angles in both of these shapes, despite that one of the shapes is smaller, will always have the same measure of angles. And then their side lengths will be proportional, meaning that I can apply a scale factor to either of these triangles that will dilate it, either increase one of them or decrease the other one, and for them to match up. So I'll leave this up for a moment. Any comments or questions about this? No. I'll leave this up for people to write down if need. Okay, main point. Similar figures. These two figures, they always have congruent corresponding angles, meaning they both have the same angle measure. Big idea number one. All right, transition. Big idea number two. For some figures like rectangles or squares, so you can see there's two rectangles on the screen, it is sufficient to focus on side lengths since corresponding angles are automatically congruent. So this is just letting us know that with squares or rectangles, all of their angles, all of the four angles on squares and rectangles will always be 90 degrees. So we already know that these are corresponding angles. And now we just need to check the relationship between each of the side lengths in our rectangles to see if there is a scale factor that applies to each side length and if the side lengths are congruent. sorry, if the side lengths are proportional. So I'm going to put this note in the chat that just says, it's just a reminder that all squares and all rectangles, all rectangles will always have 4 angles that measure 90 degrees each, because they're all right angles and that never changes. So for some figures, for some polygons, we're trying to figure out if they're similar, we'll have to look at both the angle measures and the side lengths. But with squares and rectangles, we do not have to, because we already know that they have, no matter the size of the figure, so the smaller square and the smaller rectangle and the bigger rectangle, they always have 90-degree angles. Questions on this? Sorry, that was a lot of talk. Can you just put a thumbs up if you're ready, or chat in that you're ready to move on? Thanks, Mihaela. Thanks, Jimena. Good. Thumbs up. Chat in. Ready? Thank you, Ivana. Thank you, Naomi. Thank you, Gabrielle. Okay. Good, good. All right. Big idea number 3, our last one. Okay. So for some figures like rhombuses, which these are both rhombuses on the screen, it is sufficient to say, that means it's enough to say, it's enough to focus on angles, since corresponding side lengths are automatically proportional. So this means that unlike squares and rectangles, we're not going to focus, when we have 2 rhombuses, we're not going to focus on their side lengths. We're only going to focus on their angle measures, because if you can see in this picture, it looks like their angle measures are different. We have some that are smaller and larger than others, but their sides are automatically proportional, which means that I can multiply or divide each of these sides in one of the figures by a certain scale factor that would help me increase the size or decrease the size to match up perfectly with the other figure. Let me know if I'm being confusing. I know I'm talking a lot. So those were our 3 big ideas. Can everyone just chat in, please? And I'll put this in the chat. How you're feeling about the big 3 ideas? You could do 5, you're feeling great. Or we could do scale of 1 to 3. I'll put this in the chat. Scale of 1 to 3, 3 being awesome. Actually, I'll do scale of 1 to 5. Scale of 1 to 5, 5 being awesome, feeling good, and 1 being super confused. How are you feeling? Give me a lowdown on that. Thanks, Naomi and Valerie, for chatting those in. Transition into an activity called Are They Similar? And it is in your Google Classroom. If you just look on your Pear Deck screens, you can also look at mine. It's in your Google Classroom, Unit 2, Lesson 7, Activity 2. That's what it's called. Oh, awesome. Okay, so I'm going to share my screen. Thanks, Sonia. And we'll go over this together. Okay. So here was our first question that says that we have 2 figures, right? We have a rhombus, which is this bottom right figure, and then a square, which is our top left figure, where it has all these equal angle measures. They're all 90 degrees. Priya says these polygons are similar because their side lengths are all the same, right? We can see they all have 2, oops, 1 second. They all have 2 unit side lengths. And then Claire says these polygons are not similar because the angles are different. So let's see. Okay, Miguel, I see yours. It's great. Miguel, will you share what you put for number 1, please?
The So I agree with Claire because the lengths are the same. That is true. However, the angles are way off. It literally shows that the angles have been moved instead of a normal square length. Apparently, the ones in the corners have been changed to 120 degrees, and the ones in the opposite sides are 60 degrees.
Yes.
They have the same units. However, their lengths are completely off. If being half decently smaller in a way.
Yeah. So they're angle measures. They all are two. We can all say they're 2 units, but because they do not have the same angle measures, right? The square, each of the angles are measured 90 degrees, right? Because we know that in squares and rectangles, they're all 90-degree angles, all 4 of their angles. And then in this rhombus, we can see that there's 2 60-degree angles and there's 2 120-degree angles. So that means they're not similar. So we agree with Claire. Questions about this? You can check it out. Everything we just said, Miguel and I, thanks Miguel, on my screen as well. So then we have 2 rectangles, which 2 rectangles tells us what about these angles, everybody? Angles and squares. With 2 figures, they all will always have the same angle measure, right? Okay, so then I'll dive into it. Jada says these rectangles are similar because all the side lengths differ by 2. So we'll check that. Lynn says these rectangles are similar. I can dilate AD and BC using a scale factor of 2. So line segment AD and BC. She's dilating that, she's multiplying them both by 2. And AB and CD using a scale factor of 1.5 to make the rectangles congruent. Then I can use a translation to line up the rectangles. That was super specific. Yes, they're not even diving into the angle measures because they already see that they're all 90 degrees. Now they're looking at the sides. Let's look at what Jada says. She said all the side lengths differ by 2. So if we multiply 4 by 2, does that equal 6? Is 4 by 2 6?
No.
No. So that kind of automatically we can X out Jada's response. Because, well, 2 by 2 equals 4, right? These corresponding sides of H and E, D and A, C and B, and G and F. D and C, which is 4, multiplying that by 2, or A and B by 2, which is also 4, does not equal 6. So then we can cross out Jada's. Then when Lynn says these rectangles are similar, we'll multiply D and A by 2 and C and B by 2. But with scale factors, we have to multiply every single side by the same number. So we can't just switch and do 2 corresponding sides, multiply them by 2, and then the other sides and multiply them by 1.5. We can, the scale factor is only one number. So Lynn and Jada are both wrong. Yeah, thanks, Naomi. So if the side lengths are not all scaled by the same value, you can see this on my screen, then the figures cannot be similar. So I'm gonna, 1 second. Yeah, will you read off the first, that first bullet?
I can use angle measures and slide lengths to conclude the 2 polygons are not similar.
Awesome. So check, we learned about that. Angle measures, side lengths, yep. And then Gerardo, will you jump on the next one, please?
I know relationships between angles, measures, and side lengths and similar polygons.
Great, thanks, Gerardo. Yep, so those were our goals today. Take a moment with these. Cool. I'm gonna drop a link to this cool down in the chat. It's also in your Learn Zillions under assignment, under the assignment section.